listen, and it's important, okay? Elon Musk found me, okay? He says he wants to give his money away, but only to super bright students, okay? I said, okay, fine. What do they have to do, Mr. Musk? And he's like, all right, I'm going to give you 4 options of like monetary values that are going to be given to you. You need to pick the most lucrative, the one that's going to produce the most amount of money, okay, of the 4 options. But you only have 2 minutes to make your decision. If you're able to make the correct decision and tell Mr. Musk, hey, I want this option and you owe me this amount of money, he'll give you the money. Okay? You got 2 minutes to do it. See if you can do it. Ready? Here are the 4 options that he told me to tell you. So, see how it goes. First option, he's going to give you $1 right now, but if you wait, he'll double the amount you have 30 times. So after doubling that $1 30 times, boom, here's an amount of money. That's an option. Here's another option. He's going to give you $5, and he's going to triple that 17 times. Boom. He could give you that amount of money. Third option, he's going to give you $2 billion in cryptocurrency, but obviously cryptocurrency markets are kind of crazy right now. He's going to guarantee that that cryptocurrency is actually going to decrease 5% a day over 15 days. So it's going to get lesser in value. That is the third option. And the fourth option, he's going to give you a penny, but he's going to quadruple it 18 times. Okay, you have 2 minutes to decide which option is the best option and to tell me how much money he would owe you. See if you can do that. No. The option is the $2 billion will shrink 5% per day over 15 days. No. Okay, which option is going to be the most? Oh, okay.
.01. I figured it out. The $1 time.
You got one? You got them all? That's not the penny.
That's the only.
So, okay.
Oh, yeah, 20. Yeah, bro. .01.
Wait.
You get it, Garber? Which one wins? First one? Funny how you did the first one last. Because you thought it had to be the last one. Garber, that's smart. All right, Garber gets the money.
It's the first one.
Wow, you guys don't all get the money. This is impressive. My last period had no idea. Some of you are not sure what to do. Okay? $1 billion.
Just want that amount.
Yeah, 1,073 million. What did you? Oh my gosh, were you guys like spreading it off? All right, so here's what some of you guys did. You were like, okay, $1, and then I see in some of your calculators, times 2, times 2, times 2, times 2, times 2. Everybody did that? If you did that, it's totally okay. I actually wanted you to do that. If you did this, I wanted you to do that. Okay? This is important. It's important to what we're learning. We're taking something, and then we're multiplying it by the same thing over and over and over and over and over again. Okay? Well, what's another way? I'm going to pick on you, Woods, because you love to shout things out. What's another way to write 2 times 2 times 2? What's the way to write 2 times 2 times 2 times 2 times 2? Yeah, to the fifth, right? So who amongst you did times 2 times 2 times 2 times 2? Well, you're going to get the right answer, but wouldn't it have been easier to just multiply it by 2 30 times? Wouldn't it have been easier? We laugh because it's like, yeah, okay, yeah. So it's like, how many of you did 5 triple? How many of you did that? Yeah, it's okay. It's okay. Wouldn't it have been easier if you said, take that 5 and triple it 17 times, right? Wouldn't it have been easier, instead of doing your penny, to multiply it by 4, 18 times? Wouldn't it have been easier to just say multiply by 4 18 times? And now for the third one. This is a real world situation where things decrease or increase by a certain percent. Ready? You take your $2 billion cryptocurrency and, ready? You want 5% less, okay? Decreasing by 5%, which means you start with $2 billion, you want 95% of that after a day. And then you want 95% of that. If it's decreasing 5%, you'll be left with 95% of the original value. Does that make sense? If I decrease 5%, 5% goes away, I'm left with 95%. I will take 100% of my value and I will take away 5% of the value, or I want 95% of my original value 15 times. Thanks.
Technically, is it number 3 that are number 1? Cash out all of the because there's nothing stopping you in doing that.
No, I'm sorry, Mr. Musk. It's called. If you work for a company thing, you were given stock options. It's like, hey, here is these stock options, and they're like, oh, it's worth this much, but you can't cash them out until a certain day after you've worked for the company this many years. Then you could exercise your options. I'm sorry, Fang. Elon Musk has an option for that. So what we just learned is that there are situations in the world where you take an initial amount and you multiply it by a multiplier a certain amount of time. This is called an exponential function, and we will learn more about them after lunch. Cool. So, in our situations, we have an initial amount. That is crazy. And we have a multiplier. Kind of. Many times. This is typically a function seen in the real world, where it's like, hey, COVID started with 100 infected people in a city, and we doubled the amount of infections early on in COVID for specific amounts of time. This is a very, very real world situation. Now, how do I know that I started with 100? Well, Mr. Messer told me initial amount multiplier. How do I know that I grow? How do I know that I'm going to get more? Let's think about this differently. What happens if this was f of x and I plugged in 0. 0 would stand for like no time has elapsed. What happens when you plug in 0 into an exponent and tell your neighbors? What do you get? What if it's 100 times 2 to the 0? Okay, good. So first thing that's important with exponents is exponent rules. Anything to the 0 power is just 1. So here is our idea behind our initial when time is 0. This is our initial amount. How do I know that this is going to grow? How do I know that we're not going to get smaller values? How do I know that it's going to grow? Tell your neighbors. How do I know that we're going to grow in the amount of infections and not? Because I'm multiplying by 2 over and over and over and over and over again. This is very important to understand. This means take 100, multiply it by 2 over and over and over and over again. So as long as this value is bigger than 1, or bigger than 1, we're going to grow. We are not talking about that yet, Shryari, but we will. Let's take a situation where I have $100, but I'm very generous and I give a half away every day. 100's not a good number to work with, but we'll work with it. Okay. It's very important to understand what this means. When time is 0, this is just 1. I have $100 that I start with. I will take this 100 or whatever it is, and I'll be multiplying it by a half over and over and over. 1 time, 2 times, 3 times, 4 times, 5 times. Okay? What is happening to the 100 as I'm multiplying it by a half over and over and over and over again? Okay. So what we have is a situation where we are decaying. Why are we decaying? Because we're taking our initial amount and multiplying it by a value that will make it smaller and smaller and smaller and smaller. Okay, so we learned that if your multiplier is bigger than 1, you're going to grow. If your multiplier is between 0 and 1, we are going to shrink. That's a between. And we are going to have a decay. We will never ask you to worry about a multiplier that is negative because it gets weird with negative numbers to different powers. So don't worry about negative multipliers. If I take a negative 2 squared, it's a positive. If I take a negative 2 and cubed, it's a negative. The function's going to be all over the place. So we don't do it. Our multiplier is always positive. All right, so now we have this situation where y equals a times b to the x. If b is greater than 1, we know we are going to start at a, and we will grow, and we talk about exponential growth. We are multiplying it by 2. We are doubling things that were already doubled. We are going to be increasing very quickly if we're growing. We are going to be increasing at what type of rate? An increasing rate or a decreasing rate? What is the concavity of my exponential curve? It's got to be concave up. Think about taking 100 and multiplying it by 2 and then multiplying that by 2 and then multiplying that by 2. We have to be increasing at an increasing rate. We are literally just we're going rogue here. So this is all on the back of your notes here. All right, cool. If we're looking at y equals a times b to the x and b is between 0 and 1, we are starting with values and we are going to take half of it and then half of that. It's not half, it's just like less and less and less. And we have this going on over there to the right. What is the function doing? If it's decaying, tell your neighbors in terms of increasing, decreasing, and increasing, decreasing rate.
decreasing at a market point.
Is it decreasing at an increasing rate or decreasing at a decreasing rate? Yeah, so it's decreasing. So it's like, hopefully we remember this is important.
Yeah, that's what it is. I meant that.
It's concave up. The rates are increasing.
Yeah.
That's what we remember from Unit 1, right? Okay, so this is decreasing, but guess what? The rates are still increasing, decreasing at an increasing rate. Okay, cool. But what would happen in the past? Let's say I'm using this example as, what was my example I had? This is 100 doubled, whereas this is 100 halved. What would happen if I went in the past? What would happen? Let's call this f of x, let's call this g of x. We're going to get to our homework too. What would happen if I went in the past? What did I have a day ago? What would happen if x was -1? What would happen if g was -1? Here is our growth. Here is our decay. Plug in -1. What do you do when you plug in -1 into an exponent? Tell your neighbors, what do you do when you plug in negatives into exponents? What are negative exponents? Very good. So if this is 2 to the negative first, it's like, well, if I'm multiplying by 2 and I get bigger values, in the past, I must be coming from smaller values. Or 100 times 2 to the negative first is the same as 100 times 1/2. So if I'm getting bigger values, I must be coming from smaller values so that I multiply by 2, multiply by 2. This is what an exponential growth function looks like. It never crosses the x-axis. It will never equal 0, but it'll get close to 0. The decay, halving. We got 50, 25, we got like 17, we got 8, we got 4, we got 2, we got 1, we got a half, we got a fourth, we got an eighth, we got a 16th. We are getting smaller and smaller and smaller, but we're never going to get to 0. We'll get close to 0. And if we come from the past, well, if you have a negative first power of a fraction, what do you do with the fraction? Well, it's the flip. If this 2 to the negative first becomes 1/2, then the 1/2 to the negative first would be times 2. Oh yeah, it makes sense to come from the past. I must be multiplying, and I must have started with a bigger value so that we decrease. So we can see the end behavior. The end behavior of exponential functions. And then we'll start into the notes. Is the following. In one direction, your a times b to the x will go to infinity. In the other direction, your a times b to the x will go to 0. Will you either get values that are going to get bigger as we multiply, or we get values that are going to get smaller as we multiply? But if we go in the opposite direction, it's going to do the opposite thing. If I have a decay, fill out what does b have to be and which infinity goes where. Go. If this is a decay, tell me, what does b have to be and what goes where? So if you have a value that then gets smaller and smaller and smaller, your multiplier must be between 0 and 1. It's got to be a fraction. It's got to be a decimal. Cool? As it gets smaller and smaller and smaller, as we go to the right, we are going to be getting smaller and smaller values approaching 0. As we go to the left, we must be coming from larger and larger values, like plugging in negative exponents. As we go to the left, we'll be coming from larger and larger values. So that when you keep multiplying, you get smaller and smaller and smaller. Okay? And that, my friends, is exponential function. Okay? An initial amount times something over and over and over again. We can either grow what we start with, or we can shrink what we start with, depending on our multiplier. Let's focus on F and J. Tell me. We're going to do like half of your homework. Are they, which one's a growth, which one's a decay? And what are the y-intercepts? Go. F and J. F and J. I'm going to move on. You better not be like filling in the rest of your homework while I want you to just do F and J. Okay.
Is that correct? I don't know if I got the y-intercept.
What is special about y-intercept? It's when x equals 0. We've already talked about what happens if x is 0. You are telling me if f is a growth or a decay, or if j is a growth or a decay. You are telling me what the y-intercepts of f and j are. You should know that since you're taking 2 and you're multiplying it by 4 over and over and over and over again, you are going to be growing. For f, you are going to be decaying because you're taking 4 and multiplying it by 4/9 over and over and over again. You are decaying. You understand that the y-intercepts when x is 0 will give you your initial amount, what you have at time 0. 4 to the 0 is 1. I start with 2. The y-intercept is what we consider an initial amount, what we started with that we then multiply by something over and over and over again. When we decay, j of 0. Well, the 4/9 to the 0 is not decaying anything. The 4/9 to the 0 is just 1. We just get 4. That, again, is my initial amount that I will be multiplying by 4/9 over and over and over again. We should understand that if we have a growth, if we are looking to the right in the future, we should get a bigger value. So f of 2 should be bigger than 2. If I look at a decay in the future, j of 2 should be smaller than 4 because I'm multiplying 4 by 4/9. Figure out without a calculator what f of 2 and j of 2 is. You are not using a calculator this entire unit. It was only for the Musk problem. For the Musk. Then you cheated.
No, I'm not thinking what if I did, what if we did.
Don't. Just practice working with exponents without a calculator. So, I start with 2. I'm multiplying it by 4 twice. 2 times 4 times 4. Okay, well, 4 squared is 16. 16 times 2, I get 32. Easy. If I look at j of 2, I start with 4, and I multiply it by 4/9 twice. Every time I multiply it by 4/9, it's going to get smaller. And I know it's going to be crazy, but you can do 4 times 16 over 81 and be okay with 64/81 as your answer. 64/81 is less than 4. It makes sense in the future. I'm going to get a smaller value because my multiplier is less than 1. If We went in the past. Please tell me, 2 days ago or 2 years ago, what must I have had for my growth? We are going to just do 2 at a time, Woods. So, if I'm growing, my values are going to get bigger in the future, which means in the past they must be smaller. So that I keep multiplying by 4 to get my initial value, to get my future values. So when you do 4 to the negative second, we know if you're multiplying for the future, you need to be dividing in the past. So you take that 2 and you divide it by 4 squared. That's a negative exponent. It's just division an amount of times versus multiplication. It's a really cool thing to kind of see when you look at an exponential function that, like your rule, negative exponents means like the same as a reciprocal. Well, it's like, think about it. Multiply for the future to get future values. Divide to get the past if you're growing. So I get 2/16, which is 1/8. Boom. I'm coming from a smaller value in the past to get larger values in the future. Here, in my decay situation, in the past, I must have been coming from a bigger value. This makes sense if you do the math. Take your 4, multiply it by 4/9 to the negative first. Now, tell your neighbors, what do we do with a fraction to a negative power? We should be able to do it with a negative first or a negative second power. No. I mean, yes, but like before you cancel out the bottoms, what do? Yes. Instead of multiplying by 4/9 to get the future, you need to divide by 4/9 to get the past. Dividing by a fraction is the same as multiplying by a reciprocal. So negative first power is the same as 9/4 to the positive first. If this was a negative second power, you would be dividing by 4/9 twice, which is multiplying by 9/4 twice. Or for the first power, we'll just get 9. You need to be comfortable with negative powers. You need to be comfortable with fractional powers. Hey! Did you guys get 9? All right, cool. Can we all just look at Woods and be like, what? Because we all do that. What? All right. Now, we need to be comfortable with fractional powers. Hey, if I'm given 4 times as much every year, well, what's going on in between? What's going on half of the year? We know that a half power is the same as the square root. What's a fourth power? A fourth root, a cubed root. You're exactly right. So for f, I got 2 times 4 to the 1/2. A 1/2 power is the same as a square root. If I'm doing j of 1/2, it's 4 times 4/9 to the 1/2. A 1/2 power is the same as the square root. We should be comfortable understanding that, look, we started with 2. We are on our way to getting 8. On our way there, boom, we're at 4. Now, 2 to 4 to 8, think about that. Is it linear? No. We are increasing by 2, then we're increasing by 4. We are increasing at an increasing rate. It's increasing at an increasing rate everywhere. This all makes sense. What happens if you're square rooting a fraction? Square root the top, square root the bottom. Don't be scared. I'm starting with 4. I'm on my way to getting smaller and smaller values. We are decreasing at an increasing rate. Boom. Cool. Staying on our functions, let's remember transformation. Now, I'm not going to show you graphically what the transformations look like because they're confusing. But I will tell you, and you will all write down on the top of your homework, A times f of x plus b plus c. And to help you understand, we will use a quadratic because we understand quadratics. Tell your neighbors, what did A adjust on your graph of your quadratic? Was that your phone? Yes, it was, Woods. Give it to me. Give it to me right now. Give it to me right now. You're totally looking at me. Give it to me. Give it to me. You are the worst. Why do you even try? So, Woods, I remember doing this the other day. You shouldn't have your phone at all in this class. Yo, it should be over there. Yeah, you're going to be tempted to look at it. Also, don't rat out your bros, all right? Don't rat out your bros, and don't worry about it. You're just trying to be silly.
I'm putting you in dunk.
I got you. We're cool. Yo, what does A do? Tell me.
That's something. I'm just like.
Oh, my God. Thomas, what does A do? If I change A, what does it do? Yeah, what happens if I change this number? What if I made y equals x squared, y equals 5x squared? What does it look like in terms of a transformation? Yeah, you're thinking skinnier and wider. I'm thinking a vertical stretch or shrink. This is a vertical dilation, people. A vertical dilation. You all forgot that from Unit 0. No, you didn't.
Well, I had it.
Well, all right, Linda, you're going to tell me then what, B or C? You can tell me one of the two. C. Tell me what C does. No, it's not. Let's say I take 5x squared and I add 4 to it. What is that going to do to the graph of x squared times 5? It's going to shift things vertical. This is a vertical translation. I don't even know why I'm doing this. What happens when you change B? The horizontal shift. I'm going to do this and that. But I'm going to help you out. Maybe we'll do all 4. If I'm vertically translating something up 4, all I'm changing is C. Really, I'm taking f of x and I'm adding 4 to it. Got that? Could you write f of x plus 4?
Yeah.
Write f of x plus 4. That is taking f of x and shifting it up 4. What is f of x plus 4? What? What do you guys put down? What are you putting down? See what you put down. You're doing too much. 2 times 4 to the x is that. No. I'm reminding you of transformations using the quadratic. But now we have exponential, which means we're talking about, shifting things where it's going to be a different number times A times B to the X plus a different number plus a different number. It's kind of confusing because of all the A's and the B's, so I'm going to just kind of leave this off and kind of go with the function notation. If I take F and add 4 to it, I get 2 times 4 to the X plus 4. I just vertically shifted things up 4. Is that okay? Okay. What would a horizontal translation right 1 of J look like? Yes, it is the opposite of what we think. So I would say this is J. I don't know why this keeps happening. I know. This is J of X minus 1.
But that's right. So it's like I want to buy.
So what would that look like? Okay, lock it up. We got to get through the rest of these notes in like 20 minutes. I don't know if we're going to do it. So focus. I am taking where X is and I'm replacing it with X minus 1. This is new to you. We are going to have an X minus 1 in an exponent. We will see this a lot starting next class. We will be able to manipulate things a lot starting next class. If I vertically dilated, I multiply by 3. If I horizontally translate the block, stop. I will add 2 inside my function like that. I'll let you guys try to figure out what that is. I don't know why that keeps happening. All right, we're focusing on F and J. Please tell me, what is the limit as x approaches negative infinity of F? What is the limit as x approaches positive infinity of F? Focus, focus, focus. I could go to the notes and just go through the rest of the notes, but I think this might help you better. Please tell me, what is the end behavior of F? And you should check with your neighbors, and thank you for focusing and actually doing this. Because if you answer this question, you understand what's going on. Yeah. Do the same thing for J. No, it's not like that. It's always increasing rate, so it's not curving downward. Multiplying by 4 over and over and over and over again increases really quickly, which means we must be coming from smaller and smaller values in the past. We're going to 0 to the left, we're going to infinity to the right. An exponential decay. Our value will get smaller and smaller and smaller. It will approach 0 to the right, which means it must be coming from bigger and bigger values to the left. Yeah, J is a decay because you have that multiplier that's less than 1. So J's values, as we progress, will get smaller and smaller and smaller. Okay. Another way of calling our multiplier is our common ratio, okay? Common ratio is another way of calling a multiplier. I will show you this one on the left. I will show you 2 ways to do the one on the left. I'll see if you guys can do the one on the right. Ready? If I know my multiplier is 2, and I know I have this 0.38. Well, that means I'll have the 0.416, right? Because it's like if I go to the right, I'm going to take my y's and multiply them by 2. So we can kind of think, okay, 416's got to be a point. Well, that means if I go back in the past, I'm going to have the 0.24. I'm going to have the 0.12. I'm going to have the 0.01. Because I'm multiplying by 2, multiplying by 2, multiplying by 2. Hip, hip, hooray, I have my equation 1 times 2 to the x. Now, watch this. You don't have to do this, though this is a good understanding of exponential functions. Woods? Let's say I didn't know that. Well, I know at least my multiplier is 2, but I don't know what A is. I don't know what my initial value. I found my initial value, just kind of figuring it out because I understand exponential functions. But what could you do? You could plug in your x and your y. If y is 8, x has to be 3. Guess what? We have an equation that we could solve for a. A equals 1. Now, that is a different way of coming up with your original equation. 1 times your multiplier of 2. That many times. You guys do the one on the right. Either way works. Algebraic will always be there to help you.
I know it's fun because before you put 3 days and then multiply by 4 3 months.
Yeah, but I want to get to 0. I know that my equations, y equals a times b to the x, is our initial when x is 0, and this is our multiplier. So I'm just can work my way towards, if this is a point and this is my multiplier, what do I have at 0? Or you can use algebra. Guys, maybe let's use algebra if you're confused, and that's okay. This is my multiplier. Y equals a times 3 to the x. Fill in that. Solve for a, and you have your equation. Stop using your calculator. It's so soft. 1/18 is the answer. It's easy to find. I could go to the left and divide by 3 twice. I get 1/6. I get 1/18. You should get 1/18. Now you could also double check that. 1/2 equals a times 3 squared. 1/2 equals a times 9. Okay, a equals 1/18. I get 1/18 times 3 to the x. Now, for the first two, don't have to use algebra. Multiply by 2. Okay, I'm going to just divide this by 2 3 times, and I get to 0. Oh, multiply of 3. I'm going to divide this by 3 twice to get to 0. I wouldn't do it this time. My multiply is 2/3, which means I need to divide this by 2/3 4 times to get to 0. Dividing by 2/3 is the same as multiplying by 3/2. That is going to be a little bit tricky to do, maybe mentally, but algebra is always going to be there for you, so figure out this equation. What is the equation? So, of the exponential function, that's a decay, which means we got to be starting from a bigger value so that we get smaller every time. What is A? We know what R is. Find what A is. Three, 9, 27, 81. Yo, you guys are so bad with your arithmetic. Watch. Everybody, watch. You solve by multiplying by 81/16. Did you guys all do that? I need to figure out 81/16 times 8. I'm going to write that 8 as an 8/1. I'm going to understand that the top and bottom share an 8. I will divide the top and bottom by 8. This turns into a 1. This turns into a 2. I get my answer for A is 81/2. If you multiplied 81 by 8, you just wasted a lot of time. If you multiplied 81 by 8, you wasted a lot of time. If you figured out that it was, what is that? 648. You did 648 divided by 16. You wasted time.
It'd be A equals A times 16 to the 80, right?
It's 81 halves times 2/3 to the x. What are you talking about?
Like before you distribute, after you squash or square everything by 4 is the A equals A 16 to the 80.
Cool. Moving on. I don't know what you're saying, Woods, but I like.
I got that.
Okay. Do you guys know how to multiply things together? You just need to practice. That's all it was. So what? The answer was y equals 81 halves times.
16 over 81, that's 1/8. Yeah.
No, because where's A? Where's A, Cold Tricket?
Right there. What do you divide?
What's next to A? 16 over 81. I need to get rid of the 16 over 81.
Divide 8 by 16 to the 81.
Yes, but dividing by 16 over 81 is the same as multiplying by 81 over 16. I multiplied both sides by 81 over 16 because it's the same as dividing by 16 over 81. We got this now?
Wow, we're
Yes, you did. Good. All right. Moving on. I'm going to give you a table. The table's an exponential function, which means, guys, it has an initial value and it has a multiplier. Sometimes the initial value is given to you. How can you figure out your multiplier? What? How do you figure out your multiplier? What is the multiplier? Something is getting multiplied by 2/9 to get 2/3. Something, and it's the same thing, is being multiplied by 2/3 to get 2. Something is being multiplied by 2 to get to 6. What is it? How do you find 3? Maybe without just like figuring out. You take a next value, you divide it by your previous value, you must get your multiplier. 6 divided by 2 is 3. 2 divided by 2/3. Oh, that's going to equal 3. 2/3 divided by 2/9. Oh, that's going to be 3. Your multiplier has to be consistent. You could divide any two sequential numbers the next by the previous to get your multiplier. Where people will make mistakes is they'll think a multiplier is a number when it's a fraction. They'll think the multiplier is a fraction when it's a number. Divide the next one by the previous one, or just figure out, I'm going from 2 to a 1/2. Figure out your multiplier. But hey, guess what? You are not given your initial value. You were given your initial value here, you are not. You can figure out your multiplier as a 4th, 1/2 divided by 2. But if you are multiplying by a 4th to get the next value, you are essentially dividing by 4 to get your next value. To get your previous value, you will multiply by 4. Oh, I must be coming from 8. You can either figure that out by knowing, oh, I got to divide by a 4th, which is multiplying by 4, which gives bigger values. You can either figure it out or do it just like you did the previous question. Moving on. Ready? I took 6. I multiplied it by my multiplier how many times to get 54? Twice. Boom. All of a sudden, you have an equation. You have 1, 6, 3, 54. I started with 6 times my multiplier twice. I will get to 354. There's a way to set this up and do a system of equations, but it's not necessary. You could just kind of figure it out. Now, B should be plus or minus 3, but we don't worry about negative multipliers because they look funky because of negative values to positive, and odd and even numbers get weird. So I just found my multiplier. How do I find my initial value? Tell your neighbors. If I multiply by 3 to get my next value, what do I do to get a previous value? You could either divide by 3 to get 2, or you could say y equals a times 3 to the x. I know 1, 6. 6 equals a times 3 to the first. A has to equal 2. Cool? So my setup for this is I'm taking 4. I'm multiplying it by my multiplier 3 times to get 32 27th. That's going to be weird to do, but you'll be able to figure it out. Move forward to 10, 11, and 12. Yes, you are filling all these, or I'm not giving you a check for. Real world. Percent increase, decrease. In the real world, we don't double things often. In short periods of time, we will double things. In the real world, we have small but consistent growth. 5% growth every year. 8% decrease every year. How we model that is we have our initial amount. We will either add or subtract from 100% of something, the percentage we want. I will start with 100%, and I will add my rate that I'm either increasing, or I will subtract the rate that I'm decreasing. So that if I'm growing by 5%, I want to multiply by 1.05 every year to get 5% more than what I started with. If I am subtracting or decreasing by 5% per year, I want to take my initial amount and multiply it by 0.95. So I get 95% of what I started with each year. So if I am talking about this situation where I have 4% more per year, I started with $10,000 in my account. Hurry! We would take our initial amount and multiply it by 1.04 every year to get an increase of 4% to our 100%. If I took my $100,000 car and decreased it 15% per year, I would need 85% of my value every single year. Complete your homework. What? You will not get a calculator. You will just write down this. And you will write down that. What?
Me and Grace and Eli are going to be here tomorrow. Andrew.